Hello. So that's the first exercise after the holidays, and today I would want to show you a few things how we can improve on our lists and maps. And since this is a bit of a more complicated thing all in all, I will just implement it and you can then watch. The idea is I will implement this for our map, and we might look into making that a homework for later on the for you on the list object. If you think about STL containers, which you might know, they all use iterators to allow iterating, so going through the elements in a container. With a container like a vector, or in our case our vector like QList, XList, there is not the need to necessarily have iterators, since here we can go access elements by index. But if you have a linked list like std list or a map or any other more complex data structure which does not use a consecutive memory block or some other sort of index, you have the problem that you can only access some of the elements, and the other elements are only linked to the root or head elements that you have. In case of our XMap, it's not a binary tree or alike, but it still uses buckets which may contain or something or nothing. It is not something that can be directly iterated through by index. So what we will want to do is we will want to create a iterator that allows us to go through the whole object to retrieve every single element in the object, and have this convenient enough such that one would want to use this on an everyday basis and not be it a more painful process. So for example, one more unelegant approach would be to always let the map give us all the keys. So for this you would create a list of all the keys, and then you would have a loop where you retrieve the elements for each key, which obviously means that if you have a very large map and you generate a list of a few thousand keys, then you would have a few thousand lookups to iterate through the whole map, and this is quite inefficient. If you are going through a map, usually you want to have static constant lookup time, no real lookups, just really access the memory and have your data. And with an iterator we can implement such a thing. So any complex iterator basically is a object of its own. So let's just start it somewhere. Struct as, let's call it as iter, or we could call it iter, the full name iterator. That doesn't matter. You can also have like as index or whatever name you would want for that. And let's think how such an iterator would need to operate. So as we remember, our map is technically a hash table. So when we look here, we have our list, our vector of our array of buckets, and each of the buckets can contain something, and each of these buckets is just a linked list, so it can contain an arbitrary amount of elements. So our iterator will need to know two things at least. One is, of course, the bucket index, and the other will be the current position within the bucket, which is not that straightforward, as for the buckets, as you know, the way this works is the one element points to the next, so you cannot have an index. So what we'll have is a as entry next, which will be initialized to the right value, and then it will just be increased, well, not increased, pointed to the next, and when it points to null, then it means there is nothing more in that one bucket. And we didn't call it maybe next, we call it bucket item, okay. Call it bucket item. And both are initialized with null. So what we now need will be a function that will give us an iterator that points to the begin of our entire data set. One thing to think about is how we want to detect if we have arrived at the end of the entire map. So the way this works in SDL is that you have like a begin and an end iterator, and you kind of have a defined end value which defines that there is nothing past that point. This is a very common approach. It is not necessarily the most elegant. It certainly is. It needs some getting used to if you haven't used iterators before. Usually one would expect that on the object you could call a function that would tell you whether there is something next to access or not. So just that you know what I'm talking about, I will quickly here make a very short demo. Yesterday map, oops, map, I think I need to include map, yep. The map, we take the same as here, int and int and string, std map, null is 1. Let's fill it up with the same values as we had before. 2, 3. And now if we want to iterate through all the elements in the map, we make a for. And since we're demonstrating iterators, we will iterator. So the iterator as such here is defined as a type within the map object, and the iterator will have functions, at least members, which have a particular type. We have not yet implemented this part in our iterator, so this is a bit going ahead. And then we of course need to initialize the iterator with a starting value, and then we have to check whether we can go further or whether this is already the end of the map. And here, this, as I said, getting used to concept is that you compare the iterator with the end iterator. So you don't have like on the iterator function that tells you no more results or anything like that, but instead you really just compare it using the compare operator, which is of course implemented especially like here. It's actually quite simple. They're just using the is equals operator for that, and then you have this end, which always will give you an invalid operator, iterator, sorry, an invalid iterator with which you can compare your I with. And then of course the question how to advance to the next entry. Use the ++ operator, which will then make the iterator advance to the next element. And here now inside on the iterator in this particular implementation, we have the first and the second member variable, which are just referring to the first and second entry inside our map. If you would have a list, then the idea would be that the asterisk operator would differentiate that the asterisk operator would dereferentiate the element which the iterator points to. So technically a map contains the pairs of those two elements, and our asterisk I also for a map would give us a pointer on the object which is stored inside our map, which has the first and second property, which is then the key and the value. So that's how an iterator in STL works. You can also use it to print the stuff. So printf %d %s backslash, and so we just print the first and the second, and then we will print the next first and first and second, and so on. String right here. So as simple as that. You can run it, of course, to see that it really does what I said it does. Wait, what do we have? Alright, we did not finish. Right. We have a few issues here. I will comment this out for the moment. The problem is, of course, we need to define either the element first, or we need to say to the compiler that this is a struct. So here, 1, 2, 3, it printed them out as it should. So if we go back to our map and continue the iteration, of course, you need to say that this is a struct, although I think it's easier if we just move our types, this two, here. Then we have everything defined. And as you noticed, one thing already probably on here is that when we go to the next element, we are not referring to the actual container object. We are only operating on the iterator itself. So the way the iterator works, it contains all the data it needs. And this can be done in two ways, either by giving it pointers to all the relevant internal objects of our primary container, or the other thing, what we can do is we can give it just a pointer to the container, and then it will be able to access the interesting things. So where's our iterator prototype here? And let's move this also a bit up, but we will keep this in the public section, as we will need the iterator to be definable and usable from outside. So, for example, we could, to our iterator, we could give it just a pointer to the SX map, and I think this is the simplest way. So we'll do it. I will call this M as well. Okay. Bucket index, bucket item. Right, yo. So in principle, we could have we could easily define an invalid iterator by saying that bucket index must be greater than m bucket count, and that bucket item must be null. We can, of course, later also add a function here to just test it, but for now, let's start with the very first thing. Of course, we want the ability to get the begin, so to get the initial iterator, and then to iterate through it. How we then terminate the loop, then into that we will just look in due time. The iterator, of course, needs to be made such that it either can be assigned using all the default assignment operator implementations that C++ can generate, or it needs to have an explicit assignment operator. Since for now we only have very simple types in it, the built-in assignment mechanism should work just fine. So let's go with that. So we have iterator begin. As begin is as such a const function. Well, technically in STL you have two begins and two ends. One is const, one is not, and one gives you a const iterator, the other one gives you a not const iterator. And the idea is that with the const iterator you cannot change things. I think for simplicity we will just start maybe without const. And of course one thing that is missing yet is the ability to actually get the things out of our iterator. So we will need to add here probably some not here, here some probably some function that will allow us to properly get the element. For now we can just access the bucket item and then its key and its value. That is that should be convenient enough. So let's just create our first iterator. Okay, and what do we need? Of course we need to assign m to m. We need to assign the bucket index at the beginning is 0, which is already 0, and we would need to assign the first bucket item so that we already have some valid data inside our iterator. So bucket item basically will be just m buckets from 0. We could of course also just make it even simpler. We don't give it a constructor, we just initialize everything ourselves here, which is probably more efficient since we should not create but we will need a constructor for that. But we could of course use the nice C++ feature that allows us to not have a explicit constructor but just initialize the variables like this, and then a constructor is created for us which does this initialization whenever the object is created. That makes for a bit more elegant code, and if you always initialize to the same starting values, this is much more user friendly than having to write an explicit constructor each time. So make it look a bit nicer by aligning all the members. Zack. We used such an assignment here as well already, so you should be familiar with it. So as said, here this gives us our iterators, well, our begin iterator, our first one. So let's implement the very first beginnings of our test case for iterator I is equals map.begin, and we don't have either incrementation to the next step nor any break, so we can here add a break so that we don't have an endless loop. We can get e dot bucket item key and then we have our value, and we will want to print this like we did here. So our value is our special string, so dot c string, and here we of course take the key. Oops. So now we will of course only print the very first entry in our table. I will enable this dump table here as well, so that we see how the table actually looks before we print it. And I will add a printf here that tells us that we are now testing our iterator. So let's run. Oops, something crashed. Our string was not initialized properly. Let's see why. Bucket item value. Bucket item was null. Great. So it seems no, it should not be null. Bucket 0 should contain something. Bucket 0 should contain the 2 entry. So the question is why this failed. Let's see. Our begin index buckets, bucket index 0. Does not look that wrong. So let's see m. So this m it has a size, it has a bucket count. Bucket index here for our begin is set to 0, which is okay. Then in principle bucket item should not be null, but it is. Let's see what's in our buckets table again. Intermediate 0, 1, 2. Did we use the wrong map? Map, no, that should be the right map. Map dump. What? And we broke here. Dump table worked fine. Probably dump table is doing something wrong. Yes. That should be just a pointer. Right. So our dump table had a bug where it destroyed our table while dumping it. Now it's fixed, and we see here that it properly returns us the entry from the first bucket with the key and the value. So our iterator already does something. So now we want to, of course, I++, and it now complains that there is no plus plus, so we will need to implement that. Iterator reference operator plus. Right. So bucket item is simply equals bucket item next, and now we have to check if this is null. So if this is equals null, then it means that we have exhausted the current bucket, and then we need to go to the next bucket index. So we make bucket index plus, and we will do this, zack. And there is one catch here, namely that we need to ensure that we are allowed to do it. So actually the better option would be plus this. So if we want to save program length, so we increase the value by 1, and then we compare whether the value is less than bucket count. Sorry, it must be less than bucket count. This means that there is a valid bucket and we can do it. Otherwise we leave it at null, and this means that we can no longer plus the whole thing. So here also we will make a return. So if this equals null, then return, just to be on the safe side. So in case a plus is called and we already were at the end, that we don't get it, and could here create a end function which will give us a iterator that points to the end. So here basically it's just bucket count. Index is equals bucket count, and item is null, and technically we don't even need the other this one, but if we want, because we will not access m for the end, but since we want to use the built-in comparison operator, we need to ensure that everything will be the same, so we keep this assigned, and bucket index is bucket index is set, and bucket item is null since we initialized it here to null. We could simplify the code here, I guess, to make it like this. This saves us at least a line or two. So at this point we can already to our iterator. What is complaining? We will see what is complaining. First we could make I must be not equals map.end. That it is complaining also that it does not find this operator. we might need to implement them explicitly, although I would have assumed that at least, so plus plus we implemented, but doesn't like it. Right, we didn't return a value. That one. Yes. Operator plus plus return this. Why is that complaining? Still says there is no operator. Let's see if this is true. Sometimes the IntelliSense just doesn't update. Nope. It should normally work. Don't think I forgot anything. That's the operator. We don't need const because this is just a normal iterator element. Let's see what I punct. Well, it has an operator plus plus, so why doesn't this? It will be the return value. It wants the operator to return a copy, not a. Is it now right? Let's see. Nope. Huh. Interesting. Well, the other plus plus operator, the one that returns a reference and does not, seems to work fine. So let's just stick with it, and then we will see why it doesn't work. And for this one, I guess we need just to implement the comparison operator. Paul, gleich, iterator. Let's see if this is smart enough that at least that will work. It doesn't like it because it doesn't have it. Yeah, then let's do it manually. So m is ungleich other m, or right, so bucket index. Okay, so we had to implement it manually, but it's something is not great. Alright, that should be should go with yeah. Okay. Right, and we need to return a value here if we don't want to, even if we don't want to, because it always needs one, so we just return the same thing. Right, let's see. Well, it didn't work quite well. It said it is unequal. Well, it said it is equal instantly. That is not good. Let's see why this failed. So we go to our map, go to our comparison operator. Right, so so let's compare just those two. But here, as it looks, everything is different. Bucket index is different, and item is different, and well, m is the same, but it should return false if any of those is not the same. So this should return. Oh, I probably forgot to remove it probably works, I just didn't remove the break, so this returns true, which is fine. Yeah, I forgot to remove the break, so that should have already worked fine. Okay, we have a problem. I know what happened. So when we look into here, we have bucket 2 is empty, and this point causes us to crash, I think. Also, yeah, we just printed the first 2 buckets. We need to improve our plus plus function, this one, such that here, if this is null, it will repeat the whole process. So instead of an if, we make a while. But we also need a break. Yeah, so if this is Gleichmann break, and then we do the sum. Yeah, and we can make this more elegant. Plus. No, okay, let's leave it like this. So the issue was that initially, when we entered the function, for the third bucket, we here assigned null because the buckets for this one were empty. So now instead we will repeat this as long as until we reach the end of the buckets, of all buckets, and then we will terminate either with the next filed iterator or without one, which then will indicate that it is the end of our list. And oops, that's not the right one. This one, and voila. 231, we have properly printed the content of our table. One thing that we probably should do here is to add a few more entries, just to ensure that we can handle any scenario. So what we want to test especially is the case how it behaves if we have multiple entries in one bucket. So I just hope that this will be enough to run into such a scenario. So where's our map? Sorry, I added it to the wrong map. I should have added it here to this one. Okay. Yeah, and it did not work. So let's see. Well, we have the dump. We have a lot of empty entries, but we don't have an entry with 2 entries in one entry. With 2 entries in one bucket, I mean. So let's see where we crashed. We crashed at the very start. So we crashed We crashed at the very beginning, since we start with an empty bucket, and this means we also need to make here handle this here properly. I'm thinking if we can make this somehow arrogant. Because basically what we would want in this scenario would be to just reuse a portion of this functionality. Just that we want kind of the first entry, we don't want to advance by default. So you can make here a protected function that will be only available to our CX map. This starts with next. hum 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 hum. I will just call it next, but later I will think about a better name. It will just implement this functionality. Or we could just make it set next. Could make it set next, that's nicer. Oops. Right, so we use set next here, and then we can use set next here. And nope, there. First this needs to be set. And we kind of try to set the first entry from the first bucket. But if this happens to be null, then it will try the next one and the next one and the next one until we get a valid one. Or it will advance the iterator such that begin will just return de facto an end iterator. So let's try, and then we'll still need to look into the test case, right? So this didn't crash, it's already okay. It printed it correctly. We just now need to also get the case where we will have multiple entries in one bucket. So we could try to modify our map such that we will not create so many buckets. Let's see where there would be insert. Right, we didn't implement this either. Insert pointer. Right, and here we always compute the new bucket count, which should be twice the amount, and here we compute when we need it, and here basically it just says that we want to have as many buckets as we have entries, but we could just divide size by 2. This will advise the system to generate half as much buckets as there are entries, and in this case we already here we see almost any bucket contains a value, and here we have even 2 values in one bucket. Actually every bucket contains a value, we don't have an empty bucket in this test case. And it printed x1, everything correctly. So we can of course make the test case even more strict by adding here a 3, so that we will have even more entries in one and the same bucket. And as you see, it is already quite full, and it still works just fine. So our iterator, its basic functionality is already working as it should. Let's quickly comment this back to the old way. We had it before, and now we can think about some convenience functionality. What we would want to have on our iterator that would make it more user-friendly than the standard STL iterators are. So one thing of course would be to have maybe a bool at end function which will tell us whether we are at the end or not. And the test for end, as we said, it's quite trivial. We just test whether the bucket index is greater or equals bucket count. Technically it should never be able to be greater, so we could also check whether it just equals, but doesn't make a difference computationally here which of the comparisons we do, if I remember that correctly. So we will just use this to be on the safe side. One important thing to keep in mind when working with operators, iterators, is that the iterator is only valid for as long as the original object has not been modified, which complicates things significantly in a way. Ideally, one might want to have more complex objects, a sort of copy and write behavior, which I already mentioned a couple of times, because it really saves a lot of computational complexity when just moving those objects around. But such copy and write behavior in combination with iterators makes things even more complicated, since every iterator basically can be considered a active reference. So if we would to extend our map to a copy on write, to add to it some copy on write mechanics, then we would need to take care of that inside our iterators as well, which might be something we might want to do later on, just to make our map more useful and more efficient. But for now, let's keep improving the iterators. So we'll add to it an add-end function, which should be quite a bit more efficient than using this iterator end approach. So we just want to go as long as it's not at end. And the other thing, what I'm a bit puzzled is why I couldn't add the plus operator. I mean, it's less efficient technically than this one, but it should be quite simple to implement, basically just that, and for some reason this did not compile. So first of all I will try again, and then it doesn't like that. One moment please, we should find this out. Actually, we could just look it up how it is done in STL. That's probably the simplest way. Right, now I remember. If we want not this but that one, this one wants to take this one wants an argument of our type. I think, but it's still complaining, so probably will not be happy. Okay, it says it must take an int. Right. Right, and this of course needs to be asterisk as well. I think that I will just contain one. It will not be quite that flexible. Let's see. Well, actually it contains 0. I think they did it just to differentiate, so that there are two different ones. Because like the name always must be operator something, but the plus plus variable or variable plus plus technically is supposed to behave differently. So this one should return us a full copy, and not just a and not alter the current object. So ideally we should well, if this is null, then we can just return null. This is fine, but we should create now a copy of this one. And then do it like this for the implementation to be correct. So I completely did not remember. It's not working. Why isn't it working? No, sorry, we actually want to change the current object. So they should be identical except for the I here. Yeah. Yes, it's working. So why do they then? Right. This one. Right. That's because now we are kind of ignoring a certain part of the functionality. So here, if we do this plus plus, what we want to return is the old value. So we need to cache the old value. And return the old value, but here change the current value. That's the right way to do it. That should be correct. I said we have not seen this bug now in production since we discard the return value, but just for completeness, this is how this operator should behave. So it returns the old value and modifies the current value, while the prefix operator here modifies the current value and returns the current value. But here now we can switch back to the other, since the other one is a bit more efficient since it does not make a copy. So we will stick to this. Okay, so we have our add-end function, and what we can think, of course, for the operator is whether we want to add to it an arrow function, which I think would be nice, so that here instead of writing bucket item, we could just have it like this. So we just need to add this arrow operator. First the type, so the type that it returns will be as entry. As entry stem. This is quite trivial because it just returns a bucket item. Okay, so let's run it. And voila, it still works. Okay, what else would we want on our iterator? I guess that's it. I guess this is it. So, so one thing that of course one would want to implement probably when we already have iterators would be a find function. So here we, I think, have something to retrieve the entry. Yeah, get value by key or get keys. You can also get value by key and index. Did we use it for something? I do not remember. Let's see. No, we did not use that function at all. And then we have again a get by reference. So the find function would be made such that it finds something for us. So like the get value here, but it will not return the value, but it will return the iterator. So if you find something with a find and then you have the iterator, you can start advancing the list in at least one direction. Of course, our iterator, as you have seen, only has the plus plus operator. It doesn't have minus minus, so we cannot traverse the list into the opposite, or in this case the map in the opposite direction. Since our map is since our buckets only singly linked, we cannot easily implement a reverse traversal, so we will not do that. But we could at least add a find function that will give us an iterator to the first element with a given key, and from there we can keep iterating. This will be useful when we upgrade our map to be able to store multiple values for the same key, because then we will need a mechanism how to basically iterate through it. Otherwise, just with this get ptr, we would only be able to access one element. So let's here implement our find as iterator find. It will take just a key. Yeah, and as you see here, we had here this to skip parameter so that we could in some way at least access the other entries for the given key, but with the iterator this becomes much more elegant. So we will just copy the function to begin with. Of course we need to change a few return values. So of course return our iterator. We should initialize it as end, so that if we don't find anything we return end. We look up here for our bucket. We have here our bucket. So since we found something, we can now adapt our iterator. Bucket index is equals index, and in our begin we use the set next. I'm thinking whether we need we need to set m. No, m was already set here by end. Yeah, I'm thinking whether we want to use set next to set the bucket index, because technically we kind of know that it should be there. No, actually it's more complicated, sorry about that. Because we might of course have multiple entries with different keys, but we want the first entry with the right key. So here we compare the keys, and if we find the key then we do something. And as we advance to the next one, so here should we add a break. Right, so we have our index, we have the first entry in the index, then we are advancing through the whole thing until we find an entry with the right key, then we break. So here we only arrive if we have already the right key, and then we also know that this is valid, so we can simplify this. Bucket item, we don't need to set next, we just set the current bucket item, and there will be a, let's say, catch-22 problem here, namely that the iterator will not validate the keys, and when we enter things they will be just entered somewhere. So what we would need to do is to tell the iterator for which key it is iterating, and also tell it that once it is not longer able to find the right key, that then we want the iteration to stop. So this will be a to-do. But for now we will see whether we can already use the find function, and I don't remember how we are handling insertions. Let's see. I don't think we are checking anything, we are just inserting the element, yeah. So in principle we could add, let's say, position, let's add a few more entries, let's say it's 0, and we just add a lot of zeros. A, B, C, D, E, F. Right, so first of all I will make, damn it, I again changed the wrong map. I should just remove the second breakpoint because that's confusing me. And then here, of course I wanted to change this one. Right, so here now we only are printing so that we see that we have a test case that is good. So here write buckets. Bucket 10 contains all the entries. So I will also maybe add the division here, but maybe not 3. 3 should be fine. Let's see. Ideally, we want to have a bucket with all the zeros and then something else. 0, 0, perfect. So we have the entries and then we have one different entry, which also made its way into this bucket. So now we can comment this out since this is working as far as we know. I will copy it though, and here instead of begin we will use find 0. Why is it complaining? Find consider key, that should be working. Key is an integer, right? It should be fine. Is inaccessible. Did I put this at the wrong place? I guess I put that somewhere in the protected section. Yeah, we don't want this to be in the protected section. We want it to be in the public section. Right, so this works. This checks until it's at end, and then it of course prints. So technically we don't need to comment all of that out. We can just put it like this. Yep. Okay, so here so it printed starting from F, then 1, and then it kept printing the rest of the tree. So it works kinda already. We are now just missing the proper abort condition, and then we also are missing the test for the key as such. Yeah, let's proceed with that. So we go to our map, and here we will add our iterator. Well, technically what we could do, of course, is we could make the iterator a virtual object, but this makes things too complicated. Let's keep it simple. We'll just add here a some sort of mode. Mode format is null and find is 1. I'll just use here mode, and by default of course it would be forward, and then we will switch it to find. Where was it? Here. So int.mode is gleich. Also, you might notice we will not include mode in the is not equals comparison. We just ignore it because that's easier for us here. So we set mode to find, and then we'll also need to set the key we are looking for. Then key, so we'll also now need to add the variable key for that as well. Mode and so we have mode, and then we have k key, which often will not be set, but sometimes it will. And then in our plus operator, actually in the set next function, already it is nice that we have one. We can add a few things. So first of all, here right, so if mode is equals find, then we just return, because we know that we will never need to go to the next bucket, because always all the keys for all the values for a given key will be in one bucket. They just might be mixed with other values. So one thing to add here is of course the return, and the next thing will be kind of a check to advanced further if this is not what we wanted. So while there is something and key is not equals key, then bucket is equals bucket next. Should all? That should be all. So as long as we have a bucket value, if the key is not what we were looking for, we go to the next bucket value. So we'll terminate once we run out of entries in the current bucket. We won't do anything if it's fine at the beginning, and we will return here if it's time to go to the next bucket, because we never go to the next bucket. Let's try it out. And we have a deadlock. It's running forever. Well, it deadlocked somewhere. That's strange. It should not deadlock. We just run it again. This is odd, because it kind of when I just go and break, it just points us to this line here, to this printf here. We haven't changed anything there. Why would that not work? I just terminate the console helper window. Maybe it's some internal. Yeah, it was some problem here in this thing. Okay, but it did not abort properly. It kept going. It started at 0 and it should have aborted here before 8x, but it did not. So let's debug that. We go to our map. Mode should be find and only find. This mode is not find. Mode is forward. Mode is wrong. Why is the mode wrong? So we go to find. Well, here mode is forward. What? Did I screw this up? Forward is 0 and find is 1, and mode is forward. That's the initialization, but here we already set it to a value. It should be it should no longer be null. This is what. Oh, stupid bug. Enabling more warnings would have warned about that. We used the wrong equals operator, of course. Now it should be fine. Suck. Mode find, yes. Okay. Where it crashed, which is not the worst thing. Our at end was not working. Of course it wasn't. Because it checks this value. We should change it. We should just check whether this is not null. At end with this is null, I mean. Because we might be at an end, but the because we iterated through it, but the bucket, and the bucket is exhausted. Yeah, now it works. So a A, B, C, D, F. All the entries are there. We iterated for all of them. We did not run into anything. The test case was not perfect because, as you see here, they are like consecutive. There is nothing interjected somewhere in the middle. But since we know that the 8th entry gets interjected there, we will just, or better yet, we will add 1 0 entry at the very beginning. We should have like all the 8 till F's, then the 8, and then the 0. So we have 0. We have one key in the middle of the other keys, and if we here print, we have only the right value. So our iterator works brilliantly. It is easy to use. There are small downsides to it, as mentioned. We might want to improve on it, making it a virtual object, which might contain more things, like an internal pointer, so that we don't always need to create and instantiate a key element. We could have this to be a pointer actually, and then remove mode and have key instead. Just key is either a pointer, which is null, or actually this is a good improvement. Maybe we should do it. I'm just thinking that we might maybe want to be able to add at some point a reverse iterator, so that we go into the other direction. I think probably not, since we don't want to change our list to be doubly linked. Although it might be nice. For now, let's just leave it as is, but we can still make the k a pointer. But then, of course, we need a destructor that will delete k if k exists. If key delete key. And now we of course need to so here, and so mode is fine, and we should check that key exists, although we know it always exists. Let's get rid of the mode. If we want this, we can re-edit later, or we make it a boolean or something like that. So we only have key, so now it's just if key, then bucket key is as key, right? And here, of course, key is equals new new k from key, right? That should make it more elegant. And we save memory since we only have a pointer. And not always a full instance of whatever our key might be. Of course, if the key is just an integer, it doesn't matter, but if our key would be a string itself or something even more complicated, then it is of course nice to, and it works, to have our iterators be as lightweight as possible. Right. One thing that of course also would be nice with iterators would be if they would be copy on write, since we usually are returning them, especially for the end iterator. It might be nice to have like a static value that we always return. Yeah, but for now I think this is good enough. It demonstrates how iterators work. And I think since we are running out of time, that will be it for today. I think during the next lecture we will take a look on our insert function, wherever it is. Remove insert here, and we will take a look on properly handling the mode which we have here. As we might remember, we have multiple insert modes. We have the normal mode, we have the multi-mode, and then no replace mode. So the normal mode means if there is an entry with the existing key, with the exact existing key, then we replace it instead of adding the element. Multi-mode means basically what the map is doing now. It just is adding the next thing, and then we end up with multiple values for the same key. And no replace is a mode where if there is an entry, then we don't add the current one, we don't replace the existing one, but we return false and say we could not insert the element into a list because an element with this particular key already exists. which is in some scenarios also useful. So I think this is a good thing for the next lecture to implement. And we will stop here for today. Yeah, also I have seen that your homework is, most of you have not yet submitted your homework, so I would ask you to do that before the next lecture, ideally. Yeah, and that's it. Have a nice end of the week. Bye bye.